about them so we can all hear. Basically, what I'm going to do is use a bit of liquid nitrogen to cool down the gas that's coming out of the electrolysis unit so that it's not carrying any moisture with it when it goes into the chamber. So I'm going to pour. Yes, give me just a second. Let me pour this and I will grab the mic. Liquid nitrogen is also really fun.
Do you have a bank of batteries rigged up to take advantage of any excess energy, or do you just let it burn off?
Being that this isn't break even, it doesn't really have any excess energy, unfortunately. However, I mean, it does have wasted energy, but not really anything excess. But there wouldn't be any really anything useful for. Well, I mean, I guess you could run a vacuum gauge off of it or something like that.
Sorry, I'll try to use this when I can, but it's like I have to use a lot of hands to do this, so it's going to be rare. Basically what I'm going to do is start up the diffusion pump. It should heat up and take the pressure down. Once that happens, I'll try to get it within a certain margin of pressure in which we'll pump in deuterium, turn on the high voltage. You'll see the star up on the projector, and I'll set up the detector while that's happening, and we should count fusion or neutrons coming out of the reactor. So give me just a second to set the mic down.
Like I said, this pump's probably going to take about 3 minutes to warm up. So in the process of while that's happening, I'm going to set up the neutron detector. I'm going to use the B10 tube, and I'm plugging it into a module right here that I also use with my Geiger tube. So I have to switch between the two, but I usually know when it's outputting gamma, so that's not like a huge concern, and if it does, it's emitting it that way, so I'm not fainting over it.
What's next door?
Oh, they'll be fine. Actually, a good demo to do is to show that if the gamma shield is up and it's just detecting beta, it will register a lot of counts. However, if you put this down, it will count next to nothing. Pretty much any sort of thick material will stop the gammas coming out of this. It doesn't even have to be lead, some sort of steel, or I would even venture to say that the sheetrock probably has enough mineral content in it to slow the gammas down.
Am I safe where I'm sitting?
Probably. You're fine.
Okay.
Science!
I mean, I
Possibly. Science.
I would
Possibly.
you can hardly see your
Actually,
camera.
they get the H3.
Oh, sorry. So basically what I just did was I opened one of the valves. This portion of the chamber was at air pressure, so now it's pumping back down. This is actually a really cool view to see because you'll be able to see the formation of plasma from air pressure or standard pressure, what we're breathing right now, all the way down through the pressure regime to fusion. Hopefully I'll be able to set it up as such that once we get there, it'll start generating and everything should be great.
Is your grid made of stainless steel?
Yes, the current grid that I'm using is made out of stainless steel.
What do you do with the tritium you're breeding?
There's literally not even enough to get measurable gamma radiation off of it. I mean, you could be running a residual gas analyzer or RGA on this, or mass spectrometer, and you wouldn't even be able to see the tritium unless this was running for like a year constantly.
So what he just said is you're going to be breathing in a minute.
Is that cheaper than mining it at the moon?
What were you saying? Sorry.
Is that cheaper than mining it on the moon?
Tritium or helium?
Tritium.
Well, tritium can be found on Earth, or tritium is not nearly as rare as helium-3. These reactors aren't at the efficiency required to produce enough to. It would be more effective to go to the moon, essentially. Which would be fun, anyways.
Space!
I don't think you're quite
Space!
Science in space.
Space mining when you get some space.
If you were a mad scientist of the more evil persuasion, what's the most you could do with your setup here?
I could take some uranium, and pop it in a moderator and assault it with as many neutrons as possible to try to make bomb-grade plutonium and sell it. So yeah, that would definitely... The problem with plutonium is even if I did have bomb-grade plutonium, it's so freaking hard to make the precision explosives required in an atomic weapon. Anyways, I wouldn't be able to... The biggest thing you could do with this would be some sort of paperwork disaster in which you make some sort of dirty bomb with plutonium or something like that. The infrastructure that the United States has right now dealing with nuclear materials is absolutely absurd. Like, if I walked into an airport with a piece of uranium, I could take it onto the plane. No one in security is going to have any idea of what it is. It's not going to be of harm to any person around me. I could carry it in, this is not enriched uranium, by the way, just a piece of uranium ore that would register on a Geiger counter, but not very much. Carry it in my pocket and feel totally fine about it. Yet if the person next to me asked me what it was and I said, oh, it's uranium, joking around or something like that, the airport would be shut down for, you know, God knows how long. It's absolutely crazy. Is there anyone from TSA in the house?
DragonCon? You gotta be kidding.
Okay. Alright, so I'm going to try, if you're up here, you can probably hear a little bit of a clicking noise.
What?
That's the diffusion pump starting to work. The oil is pinging off the sides of the chamber. I'm going to open this dial up a little bit more. Okay, now it's going fairly back up high in pressure. The little jet you see is where the majority of particles are trying to go into the center of the grid. It's starting to suck back down again. The diffusion pump is running fairly constantly. Most of the counts we're getting right now, a few of them may be neutrons, but I highly doubt it. Most of them are cosmic rays or things like that. But the beams you see are where the particles are actually entering and exiting the center of the grid. Any more questions while we're waiting?
How can you not get Georgia Tech to give you a little bit of money for this?
Well, the problem with research institutions is, A, there are a lot of people who have been doing this research their entire lives and did not get to touch anything in this sort of range until they were in grad or even in their PhD studies. So you get a lot of anger there when you walk into their office and say, hey, I'm generating neutrons at a flux of millions per second. It seems like to them that's inflated or something like that, and it sort of makes them angry. Also, a lot of people have really strict ideals when it comes to fusion. They say fusion can only be done this way, and everything else is just a waste of time or playing around.
So short answer, people are assholes.
Or jealous.
It's unfortunately not everyone is as willing to have an open mind about things.
Your light just went out.
Oh yeah. So the diffusion pump has started to work really well now, meaning that we can try to put some deuterium inside of the chamber. I'm going to close. Oh, there we go. So now we have deuterium into the chamber. You'll notice that it looks a little more purplish, which is characteristic of deuterium. So I'm going to let the pressure go back down again. Voltage come back up. This is where it gets really handsy. Pressure is dropping. Oh, there we go. Okay, let me get it into the sweet spot.
Because it's required to be a vacuum for the reaction to take place. Kind of like the way they do that to be a vacuum for the light bulb.
More deuterium in there. Let gonna get the detectors.